Hey everyone, and welcome back to Chapter 4. This is section 4.4, which deals with evaluating trig functions of any angle. So not just acute angles. Now we're branching out a little bit, you guys. Okay, so basically that's it. And in order to do that, we're also going to learn about reference angles. And then we're going to use this to evaluate trig functions of real numbers. Okie doke, here we go. So remember when we defined trig functions, we restricted it to acute angles, right? So now we're going to extend that definition to talk about any angle. So then, so when theta is acute, it's going to this is kind of like the umbrella, okay? So it falls under this category. So remember we said, let's say you have theta is an angle in standard position, meaning that one of the sides of the rays, you know how they consist of two rays or two lengths meeting at one point, the vertex. Well, the vertex at the origin, one of the sides is on the x-axis and the other one is somewhere on the plane. And then you have here xy is a point on the other side of theta, terminal side. And where you have, see this picture, r is equal to the square root of x squared plus y squared, which is non-zero. Okay, so if you have that, the following trig functions hold, okay? So sine of theta is y over r, cosine of theta is x over r, tangent of theta is y over x, cotangent of theta is x over y, where of course the denominators cannot be zero for the secant, cosecant, tangent. I mean, basically all of them. R will never be zero because it's a positive distance. Okay, so then you have secant of theta is r over x, and cosecant of theta is r over y. Okay, so we're kind of branching out a little bit. Okay, so because the radius, which is equal to square root of x squared plus y squared, cannot be zero, it follows that the sine and cosine functions are defined for any real value of theta. However, when x is equal to 0, tangent and secant of theta are undefined. For example, tangent of 90 degrees is undefined. And similarly, when y is equal to 0, the cotangent and cosecant are undefined. Okay, so let's say here we have let negative 3, comma 4 be a point on the terminal side of theta. So let's see, so remember the terminal side is the side that's not, is where the angle ends. So let's find sine, cosine, and tangent of that angle. So if we look at the picture here, we see that x is negative 3, y is 4, and then you have r squared is equal to square root of x squared plus y squared. And then plugging in all the values, you get that r is equal to 5, right? And you can kind of see that if you were to drop a perpendicular line coming from the point to the x-axis, you would see that it creates a right triangle and 3, 4, 5 triangle, okay? So now we have x is negative 3, y is 4, and r is 5. So with that, we can find sine of theta, cosine of theta, tangent of theta, right? We know that sine of theta is y over r, so this is like in general, it's not just unit circle. That's why we have an r instead of a 1. For the unit circle, remember that the radius is 1, so that's why when we first introduced it, it was just sine is y and cosine is x. But now we're extending it, right? So now we can say, okay, sine of theta is 4/5, cosine of theta is negative 3/5 because it's, x is negative, and tangent of theta is y over x, negative 4/3 because the x was negative. Okay, instead of always thinking about that, you can easily determine the signs of the trig functions in the quadrants depending on, what quadrant it's in, So let's say, for instance, because cosine of theta is defined as the ratio of x over r, you can kind of see that cosine of theta is going to be positive wherever x is positive. So where is x positive? It's positive in quadrants 1 and 4. And remember, of course, r is always positive. So here's a cool picture. So see here we have look at the picture on the left. Okay, so quadrant 1, what's up with quadrant 1? Well, quadrant 1, x is positive, yeah? For any point in quadrant 1, y is positive. And then, of course, theta is between 0 and pi over 2, or, 0 and 90 degrees. Okay, so quadrant 2, so let's continue. So for quadrant 2, notice that the x values will be negative, the y values will be positive, the angle theta will be between pi over 2 and pi, so it'll be between that, yeah? Or in other words, in degrees, it'd be 90 and 180. Okay, so you kind of see what I'm doing here. So quadrant 3, so notice that x is negative, right? Any point that will be in quadrant 3 has the following properties. X will be negative, y will be negative, and theta will be between pi and 3 pi over 2. And then quadrant 4, notice that any point in quadrant 4 will have a positive value for x, a negative value for y. It doesn't matter which point it is, who cares, as long as it's in the quadrant, yeah? And then theta is, of course, between 3 pi over 2 and 2 pi. So why do we even talk, why talk about that? Why make this observation? Why should we even care about that? Well, if we notice that, and if we make those following observations, we can continue and say, well, wait a minute, sine is y, and cosine is x, and tangent is the ratio y over x. Because you know this, you can go ahead and say, oh, well, if the angle's in quadrant 1, sine is positive, cosine is positive, tangent is positive, because of these properties. So sine is going to be positive in quadrant 2 as y is positive, cosine is negative, so therefore the tangent will be negative. Okay, it doesn't matter what theta is as long as it's in in quadrant 2, yeah? And then for quadrant 3, sine is negative, right? Y is negative, cosine is negative. Negative over negative is a positive, so that's why tangent is positive. And then quadrant 4, sine will be negative, yeah, the y is down here. Cosine is positive, yes, positive x-axis. And the ratio will be negative. Negative over positive is a negative. Okie doke, let's go to reference angles. So we can figure out the exact values of trig functions for angles greater than 90 or less than 0. We can figure that out using their values at using the acute angles called reference angles. Okay, so a reference angle is basically, let's say you have some theta in a standard position. Okay, the reference angle is the angle that we could call it theta prime. The book calls it theta prime. It's an acute angle that's formed by the terminal side of theta and the horizontal axis, meaning, so let me show you what that means in a picture. Of course, we love pictures. Boom. Okay, here's some examples. So obviously, if my angle ends in quadrant 1, who cares? We already know that. We can use use what we know. But let's say we have here an angle that ends in quadrant 2. Then we would say our reference angle theta prime, is the angle that is supplementary to the original theta. Okay, so this is the reference angle. So theta prime, since it's supplementary, it would be 180 minus the original theta, or in radians, we would think of it as pi minus theta. Okay, so here, if I have an angle theta that goes all the way to, and it ends up in quadrant 3, well, then the reference angle would be the angle that this side makes with the horizontal axis. So it's basically just this here. You would subtract 180. It's not supplementary because see, for an angle to be in quadrant 3, so notice that theta goes from the positive x-axis and goes all the way past pi, and it ends up here in quadrant 3. So we want the acute angle, so we're basically taking theta and we're subtracting 180, or we're subtracting pi, and that gives us this little chunk, this little piece that we actually want to look more closely at. Okay, and then finally, if you have an angle in quadrant 4, right, notice that it would go from the positive x-axis all the way around counterclockwise into quadrant 4, okay? So basically, it's almost 360, right? So if we wanted to find the reference angle, in other words, the angle, this little, kind of looks like a Pac-Man, I guess. This kind of looks like an extended Pac-Man, like a duck or something. It looks like those little wooden beak ducks that, they dip in the water. I don't know. Anyways, this theta prime could be found by subtracting theta, the big theta, from 2 pi, right? Because the entire thing is 2 pi, right? Going from zero, from the positive x-axis and looping all the way back around, that's 2 pi or 360. So in order to find the reference angle, you would subtract theta from 360. Okay, I'll let you think about that. Let's do an example. Let's do some super fun examples. Okay, so let's find the reference angle theta prime when theta is 300, 2.3, and negative 135. So let's do that. So let's go ahead and look at it. So for A, so 300, where's 300? 300's all the way the heck over here in quadrant 4, okay? So what angle does this side make with the x-axis? Well, if theta is 300, what's left? 60 degrees, right? To get back to the beginning. So your theta prime will be 60 degrees. Okay, so that's the picture right there. That wasn't easy. So 2.3, that's a little bit more difficult, but it's still solvable. So we know that pi is 3.1416 approximately, right? So that's this here, that's 180 degrees. Pi over 2 is about 1.5708. So since 2.3 is between that, I know that this angle ends in quadrant 2. Okay, so the angle lies in quadrant 2, and its reference angle would therefore be pi minus 2.3, right? It would be whatever supplementary to it. So that's it. So you just take pi minus 2.3, and then you approximate that, and it's going to be approximately 0.8416. Okay, so that's this picture here in figure 4.31. You can see it here, where you have theta is 2.3, goes all the way to quadrant 2, and then to find theta prime, you just take pi and you subtract the 2.3. All right, now let's do this super fun one where you have negative 135. OMG, what do I do with this one? So starting here, notice that theta starts from the positive x-axis, but then loops clockwise, right? Remember that negative angles go clockwise, positive angles rotate counterclockwise about the origin, yeah? Okay, so fine. So then we know here it's negative 135, and it ends in quadrant 3. Okay, so what's my reference angle? Okay, so let's think about that closely for a second. There's multiple ways you can do this, right? In this case, we're saying, okay, well, what do I observe? I observe that negative 135 and 225 are coterminal, okay? So that's one way to think about it. And then you can say, okay, well, what's missing then? If I'm thinking of this angle, if I'm saying it as 225, then I just need to subtract 180 from 225, and then I get 45. Another way to think of it is you just want to figure out what this little piece is. Well, since it's almost 180, right? But if you think about it in the negative direction, it's going to be negative 45, but we're actually considering it in the positive direction. So that's why the book tells you to use the coterminal angle of 225, which is fine. It's fine. Okay, so trig functions of real numbers. So how do I use a reference angle to evaluate a trig function? So let's look at this. Oh, I love this picture here. So let's say you have this point xy here on the plane, and if I draw a line, or if I see the angle that ends at xy, right, where the the standard way of drawing it, where the one of the first part of the angle, one of the sides of the angle lies directly on the positive x-axis, and the terminal side is somewhere else on the plane, and in this case, it's in quadrant 2. Notice that the r is the hypotenuse, right? I can imagine a right triangle. If I drop a perpendicular line here from point xy to the x-axis, I have here theta prime, right? And the opposite of theta prime, the opposite side, is really just the distance y, so the absolute value of y. That's why we say absolute value of y. And the adjacent side of theta prime, of this right triangle that we've created, is merely the absolute value of x, and of course we use absolute value of x because distance is never negative, okay? Well, right now in this case, distance is not negative, right? So we're thinking of it as a distance, sorry. Okay, so what else do we know? We know by definition that sine of theta is equal to y over r, and tangent of theta is y over x. So for the right triangle with this acute angle theta prime and the sides of lengths absolute value of x and absolute value of y, we have that sine of theta prime is absolute value of y over r because it's opposite over hypotenuse, and that tangent of theta prime will be absolute value of y over absolute value of x, right? Opposite over adjacent. So what does that mean? That means that sine of theta and sine of theta prime are equal except possibly in sine. So that's true for tangent of theta prime and all the other trig functions. So in all these cases, the quadrant in which theta lies determines the sign of the function value. Okay, so let's see. Okay, so let's find this value. So how do we use this here? We find the value of a trig function at any angle. We determine the function value of theta prime, and then depending on the quadrant where theta lies, we use the appropriate sign. And you can use that picture that I showed you guys in the beginning, okay, to figure that out. So now, because of this, we can know more. We know more exact trig values, okay? And then you can kind of see how people will use triangles to populate the unit circle also. So it's kind of cool. There's a way to connect it. And here's a table, super fun table, where we have the common sine, cosine, tangent, and we have common degrees and radians. So, pi over 6, pi over 4, pi over 3, pi over 2, pi, and 3 pi over 2. And here are all the values, okay? So these are the common, the exact values of some common angles. And this is really helpful to have. I would take a screenshot of this or write this down or what have you, and then just have it next to you when you do problems in the homework. Okay, so let's evaluate each trig function. Let's evaluate cosine of pi over 3, tangent of negative 210 degrees, and then cosecant of 11 pi over 4. Okay, so let's start with pi over 3. 4 pi over 3, sorry. I said that wrong. Okay, so where does 4 pi over 3 lie? So let's look at this cool picture. So 4 pi over 3 is a little bit more than pi, less than 3 pi over 2. So it's right here in quadrant 3, yeah? What's the reference angle to 4 pi over 3? The reference angle is pi over 3, right? Because we subtract the pi from it, and we see this is the acute angle that it makes with the x-axis, okay? So we know that cosine of 4 pi over 3 is going to be negative, yeah? Because, we also know that cosine is going to be negative because it's in quadrant 3. The x value is negative, so that's going to be a negative cosine of pi over 3. So since we know cosine of pi over 3 by now, the solution will be negative 1/2. Okay, now let's do negative 210 degrees. So here we go. 210 degrees in the negative direction takes us past pi in the negative direction and leaves us here in quadrant 2, okay? And so what's the reference angle? Okay, so what's the reference angle? So if I take, I can do this one of two ways. I can think of it as 210 minus 180. The difference will be 30, and there it is. Okay, or I can do coterminal. What's it coterminal? How do we find a coterminal angle? We add 2 pi to it when it's negative, and there it is. Or you can add 360. In this case, it's degrees, so let's add 360. We get 150. So now we're thinking of it as 150. Fine. So it's supplementary to to theta prime, which is 30. Okay. So yeah. So that's it. So this theta prime is going to be 30. Okay. And we know, what else do we know? We know the tangent is negative in quadrant 2. Okay. So we know that tangent of negative 210 will be equal to negative tangent of 30 degrees, which happens to end up being negative root 3 over 3. Okay, and then finally, let's do a cosecant of 11 pi over 4. Okay, so where's 11 pi over 4? Yeah, so where is that? So we go 11 pi over 4, it's about, let's say if we turn that into a mixed number, think of it like that. It's 2 pi, right? It's 2 3/4 pi, yeah? So if you do that, so look at the way that the pink arrow goes. It starts at x and it goes one whole rotation around back to the positive x-axis, and then it goes on 3/4 pi, yeah? So it ends up in quadrant 2, okay? So it's coterminal with 3 pi over 4, okay? So coterminal with 3 pi over 4. So what does that mean? That means that the reference angle will be pi over 4, yeah? Because we want to know the acute angle it makes with the horizontal line x, right? So theta prime is pi over 4. And what else do we know about cosecant? Cosecant is positive in quadrant 2. So cosecant of pi over 4, it's 1 over sine of pi over 4, which ends up being root 2. Okay, so that's it for 4.4. Super fun homework, 1 through 23 odd. And good luck, and I will see you guys on the next video.